Good morning, guys. Again, my name is Alfred from Johnson Controls. I'm one of the service technicians. I do a lot of factory startups and repairs. I'm just here to go over the basic operation and maintenance of the split systems that you guys have here on site. This is like a 4-day course, really, so I'm just going to get down to the basics because we don't have that kind of time. So let me start out with the blower section, because there's a blower section which is the evaporator, and then this split system, the condenser located somewhere outside. Then you have the line set that connects both for the refrigerant flow. This sequence of operation for the blower, with continuous blow, you set the room thermostat fan switch to the on position, a 24-volt signal provided to the G1. By the way, after we finish here, we'll go by the actual unit, and if you have any questions, we can go over whatever we already went over here. So you set the room thermostat fan switch to the on position, a 24-volt signal provided to G1 terminal directly from the thermostat or from the condenser, which is a heat pump, closes the coil of the fan motor relay, which is BR1. Relay BR1 controls the coil for contactor M1. Contactor M1 controls the indoor fan motor, which is the fan motor 1, which is FM1. That they break it down in abbreviation. So when we go by the unit, if there's anything you don't understand here, we can point it out and go over it at the actual unit. Intermittent blower is to set the room thermostat fan switch to auto. Continuous blower, you set it on. For intermittent blower, which the blower only comes on when there's an actual call for cooling or heating. So set the room thermostat fan switch to auto and set the system switch to auto or heat during a call for cooling or heating. The 24-volt signal provided to G1 terminal directly from the thermostat or from the condenser or heat.
I'm sorry. Those units, what we're talking now, that's split.
The heat pumps, yeah.
It's a heat pump, right?
Yes.
It's not just a regular split, which is a split. It's most of the time it's just for cooling.
Right.
Only.
Right.
But that is a heat pump.
Well, it's a heat pump. I still don't know why it's a heat pump, because this is they're providing cooling for the elevator rooms. I don't know if they'll ever need heat in there, but.
We do have fan coil units in EMRs.
Okay.
So fan coil units are responsible for the heating in EMRs, and then we have split systems for the cooling.
Right. Well, the only one I've seen so far.
It works also for heating,
No.
or not? Here not, right?
No.
Just for cooling only.
Yes.
But it may.
You could, I guess.
Yeah,
How is it connected? It may also
Right.
be for heating, right?
I'm not sure if this particular one, I've never explored it, whether the units that we have on site could be expanded into heating too. But technically, the split systems could serve both purposes. I'm just not going to.
It can. There is a reversing valve, so it's a heat pump. So it was ordered for both heating and cooling, but the application is cooling only.
Okay.
Cooling sequence of operation, single stage evaporator unit. No additional input signal is required to operate the evaporator unit during cooling. The evaporator coil operates with only one system of cooling. Dual stage, which would be a 2-pipe evaporator unit. I'm assuming there's a lot of different sizes of units here.
There is
So,
a couple, yes.
right.
IPS are smaller than EMR.
Right.
Then we have electrical room that is even smaller than IDF. So yes, I
Right.
think we have 4 stations
But-
throughout the building.
They are going to be the same sequence of operation, it just varies in tonnage. When the thermostat calls for the first stage of cooling, which is Y1, a 24-volt signal is provided to the S1 terminal directly from the condenser or heat pump. This signal closes the coil of the solenoid control relay, and the evaporator coil operates the lower refrigeration system only. When the thermostat calls for the second stage of cooling, a 24-volt signal is provided to the S2 terminal directly from the condenser or heat pump. This signal closes the coil of the solenoid control relay. The relays RY1 and RY2 operates in series, then energizes the solenoid valve, allowing refrigerant to flow through the upper refrigeration system. Note, the unit controls are designed to allow lead lag compressor operation. When both compressors are operating, the solenoid valve opens. If either compressor stops, its matching solenoid control relay closes, thus shutting down the upper refrigeration system. On a dual stage, which would be a 4-pipe evaporator unit, no additional input signal is required to operate the evaporator. The evaporator coil operates with 2 independent and fully intertwined systems of cooling. Maintenance for this evaporator section is filters must be cleaned or replaced as often as necessary to assure good airflow and filtering action. To remove filters through the side of the unit, remove this solid side panel from either end of the unit. To remove the filters from the front of the unit, open access panel. The filters can be lifted out through the access panel. The drain pan should be inspected regularly to assure proper drainage. Blower bearings and motor bearings are permanently lubricated. So this motor, again, is a sealed motor. You cannot field lubricate it. Is there any questions on the indoor unit? Okay, so the outdoor unit operation, which is either going to be just a condenser or a heat pump, depending on what they have here on site. This series of heat pumps come from the factory equipped with smart equipment. So controls to monitor all unit functionality and safety controls. Safety controls. The Smart Equipment Control Board incorporates features to monitor safety circuits as well as minimize compressor wear and damage. An anti-short cycle delay is utilized to prevent operation of the compressor too soon after its previous run. The anti-short cycle delay is initiated on unit startup and on any compressor reset or lockout. The Smart Equipment Control Board monitors the following inputs to each cooling system. First one is a high pressure switch is factory installed to protect against excessive discharge pressure due to a blocked condenser coil or a condenser fan motor failure. During cooling operation, if a high pressure limit switch opens, the Smart Equipment Control Board will de-energize and associated compressors and initiate the 5-minute anti-short cycle delay. If the call for cool is still present at the end of the anti-short cycle delay, the control board will re-energize and halt the compressor. If high pressure switch opens 3 times within 2 hours of operation, the smart equipment control board will lock out and associated system compressors will deliver an error message. And all of these error messages is going to be a code, and in the operator's manual, you can go over and see what code is associated with the error, and it will tell you a series of reasons why that code appears, and that's where you guys have to start the troubleshooting. Or you can call tech support from Johnson Controls, and they will lead you right to where you gotta go. A pressure switch is protected. A pressure switch to protect the unit against excessively low suction pressure is standard on all condensing units. If the low pressure switch opens during normal operation, the smart equipment control board will de-energize the compressor, initiate an anti-short cycle delay, and shut down the compressor fans. On startup, if the low pressure switch opens, the smart equipment control board will monitor the low pressure switch to make sure it closes within 1 minute. If it fails to close, the unit will shut down the associated compressor and begin an anti-short cycle delay. If the call for cool is present at the end of the anti-short cycle delay, the control board will re-energize and halt the compressor. If a low pressure switch opens 3 times within an hour of operation, the smart equipment control board will lock out the associated compressor and will deliver an error message. And there's a LCD screen on that control board, and that's where the message, the error will appear.
How to reset that in this case?
I'm sorry?
How to reset that in this case?
Well, you can cycle power, but when there's an error code, the first thing you got to get to is the reason, because it's only going to happen again, you know. Sometime either right away or sometime down the road.
But what needs to be done if it's with that error?
Well, if a low pressure error code shows up, either you have a fan which is not putting enough air across the evaporator coil, or you have a leak in the system, there's a lot, right, there's a...
But what we need to do in this case, call technician or what, because we don't work with Freon here.
Oh, so you guys are not EPA certified?
No.
Okay.
No.
Well, that's where your boss comes in. And I guess they'll either call us.
EPA certified.
Huh?
Our boss is EPA certified.
Cool.
Well, I'm sure you guys have some kind of contracted company who. You guys have some kind of contracted company who comes here and look over that stuff, right? An ambient air switch will lock out mechanical cooling below 45 degrees. The compressor will run 10 minutes on and 5 minutes off. If the product was equipped with from the factory with a low ambient option, and the unit will operate down to 0 degrees. If it came with a low ambient option, which I don't know. If the unit was not ordered with the factory low ambient option, the field installed low ambient kit is available. The refrigerant systems are independently monitored and controlled. On any fault, only the associated system will be affected, by any safety preventative action. The other refrigerant systems will continue to operate unless it is affected by the fault as well. Compressor protection. In addition to the external pressure switches, the compressors also have inherent protection. If there is an abnormal temperature rise in the compressor, the protector will open and shut down the compressor. The UBC incorporates features to minimize compressor wear and tear. An anti-short cycle delay is utilized to prevent operation of the compressor too soon after its previous run. Additionally, a minimum runtime is imposed any time a compressor is energized. An anti-short cycle delay is initiated on unit startup and on any compressor reset or lockout. Conventional non-heat pump single-stage thermostat is required to operate the heat pump in cooling mode. Well, all that stuff is already installed, so these are just installation information which you guys don't really need. So if you want us to go by the equipment and we can go over anything else that you're not clear on, then we can do that now. Okay, guys, so this is the evaporator section. This is a two-pipe system, so most likely it's like a 7.5 ton. The first thing we're going to do is turn it off from over here, which the thermostat is located behind us over here. I'm sorry. This is just a sensor. That's the actual thermostat. This is a sensor to calculate the difference between here and over there, and it makes a calculation.
This is also a controller.
Yes. Because
I lowered it down to 65. It got cold.
Right. So right now we are going to kill the power to it.
You sure? Condenser is going to freeze up.
The condenser should stop running.
No, it will not.
Oh, that's how they have it set up?
So this is your fan shut down, and the condenser still works. If you kill condenser, fan is going to lose power, but if you're going to kill the fan, condenser still has power.
Well, in any case, let's leave it on then. The filters. This is the filter axis on the side here. But of course the threaded rod is across the door that the filters slide out, so you guys might have a little bit of an issue getting it out this way. So if you come in the back of the unit, this is the return side, you can see the filters there.
Filters looks better already.
Yeah, well, from construction they're dirty, you know. And then this is the outlet. But of course on installation, this door was supposed to be kept clear of anything, but that's not the case here. And of course, these are the refrigerant lines, suction and liquid. And the drain line, which have to periodically maintain by making sure it's clear. And This,
We maintain.
this drain line should have been trapped. This should have been trapped, but it's not. So
Is it access to over there to clean or how to get to it? What to do?
the installers would be the one who will let you know that. This is external from my unit, so this is all field installed. Like I said, this should have had a drain trap, and I already see it doesn't. So should have a U-trap. I already see it doesn't. So the air handler doesn't pick up any smell from the drain. But
The plastic right here.
that's installation.
So we have to mark that down, that the condenser will keep on running. So there has to be some.
Well, the way how they wired it, or the field wire it, if they shut this down, the condenser continues to run, and then this is going to freeze up.
Yeah.
But it could have been wired differently, but I'm not going to get into that.
Where you're operating at, right? Our equipment should be here. It's looking for us.
So only when you shut the condenser, this will shut off.
Electrical unit, that's what it is.
I'm not here for the field installation, you know. So, and of course the lines are nicely insulated for condensation. So, and is there any questions?
This unit cooling only.
Cooling only, but has the potential to do heating. But it's a cooling only application. But it is a heat pump. Once it has a reversing valve in the outdoor unit, it's a heat pump. Once there's a reversing valve present. Well, keep in consideration that if somebody's working on the elevator room in the winter, they might want to heat it up while they're in here. You know, if there's no heat provided by the motors and nothing, they might want to switch it to heating.
The little thing in the corner. Single cage fan for you.
Well, we already went over that yesterday. But that's the heat for the room. Okay. I know what you said. So,
Keep the room, but
so this is a fan coil unit. We already went over that yesterday for the elevator room. If any heat is needed, so. And you were right, that thermostat is for the fan coil unit. So, didn't even notice that sitting there. Excuse me.
Yes, definitely come on.
let's see how much they insulated this room.
Of course, if you ever have to,
That drain line looks better because it's no excess at all. Afterwards, I ran nothing. It's black somewhere.
You're gonna have to cut it and put a P-trap.
You see, it's a glue on it.
this is not a direct drive. There's a belt in there. So you can see this would be the belt access where that yellow tag is. And if you if you ever have to work on the unit in any way, make sure you lock and tag this box, so never just go ahead and shut it off and start working. So lock and tag the disconnect switch before any kind of work is performed. So, any questions?
How to get to filters, how to get, if it's drain, will the clog, how to clean it.
Other side,
On other side,
there is a pan Right about this line, there is
Yes, it
a
is a
plastic
fan,
pan
yes.
that you could get to. You could also remove the filters and get from that side. If you get from that compartment, pretty much right down to
But usually that plug, look, usually those plugs somewhere on elbows, right?
Well, usually there's a service.
We use a rim. But here how to get with a rim?
Right.
What's another?
Usually there's a service track installed here, and you put a suction device that would suck from the track and anything that's in there.
you
But-
could get. You
right.
could pretty much, as soon as you open any compartment,
Right.
except for this one because of the evaporator coil, I think that how it's set up, but you're going to get to it
This
as well.
also, right?
Well, this is where you have evaporator coil. I don't remember if it's pointed this way or that way. Let me see. I know for a fact because we didn't have problem with this and we had no problem getting to the drain canal.
So we can start heading out to the outdoor unit. And that's a condenser or heat pump if it has a reversing valve.
Okay, good. One question, do you still need to come back in here?
No. I'm sorry? Oh yeah. Thank you. The only thing is
Just come down and I'll be the last one to walk out and I'll return the service.
the only thing is after we shut the condenser outside, might need to come back in here to make sure this restarts in here.
Okay, that's
Okay.
fine. Yes, I'll keep the doors open.
You ready? Okay, gentlemen, so this is the condenser. And if equipped with a reversing valve, then it's a heat pump. We will know that in a little while when we take the covers off. And then I can indicate to you whether it's a heat pump or if it's just a condensing unit. Now, before we do anything, we want to kill power to this unit for safety reasons. And just as indicated here, where you see a lock and tag out, that would be the same procedure we would have used here if you were doing work on the unit. So we're gonna go to the electrical panel, which is right here. Where the smart LCD board is located. So this is the LCD board. All the error codes would be shown up here. And there's also an equipment called a map gateway that can be plugged into this board in order to navigate easily through the settings to get data on what the unit did over a period of time. All these relays are what we spoke about earlier. Of course, this is where the power comes in, so you want to make sure you check with your meter to make sure there's no power, even if you close the disconnect, because you don't know if the disconnect is defective. Because this is a $460-volt unit. So that's not something you want to play with. Condenser fans on top, 4 condenser fans. Capacitors for each fan. There's 4 capacitors for each fan. And it's a phase monitor. If the phases are backwards, the unit won't even come on. It will have a red indicator inside. Let you know that the phase is not correct. Back in the day, you would have to see what direction the compressor is pumping, or well, this won't even allow it to go into operation, which is a good protection for the compressor. And for us to see the actual compressor, we have to go in the back. So these are the two compressors, the liquid receiver. Over there, we know this is a heat pump because this is a reversing valve right here. So if you guys want to come over and take a look, the condenser coil, we know we got to keep an eye on making sure it stays clean, because then it will go into a high pressure limit. And also the fans, make sure they're always operational. So these coils, at least once a season, you want to make sure that we put a power wash to them and wash only in the direction of the coil, because if you wash across, you create damages like what we're looking at here. And of course, these are the refrigerant lines coming in that we saw inside. And each of these, the micro processor controller for each compressor. So they will shut the compressors down on any indication if something is wrong. Each of these compressors have an internal overload. So if the compressor is overheating in any way, that internal overload will trip and the compressor will not restart until it cools down. And there's always will be an anti-short circuit delay on any reset, so it will not come on right away. There's going to be a countdown from like 100 and something seconds on an anti-short circuit delay before the unit actually restarts. So you guys take a look around if you have anything that is not clear. And of course they have the schematics and the wiring diagram for any further troubleshooting that you have to do, located on our panel. And of course this is good that they have these units on vibration isolators, which is a plus for the lifetime of the unit, and also for noise reduction and vibration. So nothing complicated. So any further questions during maintenance, you can always reach out to Johnson Controls, and we'll always provide that information or provide a technician to come out and help you guys out, because we want to stand by our equipment. So in order for us to do that, we stand by our customers. It was good meeting you guys, and thanks for showing up and to give me the opportunity to explain the equipment. Thank you.
Thanks.
You're welcome.